Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment and share the video to help spread this free series of videos. Thanks for your help. Also, remember to sign up via the link in the description to get all of the lab files for this course, so you can try it out yourself in Packet Tracer. If you want more labs like these, I highly recommend picking up Boson's NetSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like Packet Tracer, but it's even better, and it includes all of these guided labs to not only help you get hands-on practice configuring and troubleshooting, but also deepen your understanding of the exam topics. I used it myself when studying for my certifications, so I feel confident about recommending it to all of you. If you want to get your own copy of NetSim, please follow the link in the video description. Also, watch until the end of this video for a bonus look at an OSPF lab in Boson NetSim. In this lab, we'll do a bit of OSPF configuration and troubleshooting. Most of this network is pre-configured, except for a few things. However, there are a few misconfigurations. So let's complete the configurations and then troubleshoot the misconfigurations. By the way, because there is troubleshooting in this lab, I highly recommend trying it out yourself before watching this video. If you see my solutions to the problems, you won't have the opportunity to figure things out yourself. Okay, let's get started. First up, in step 1, we have to configure this serial connection between R1 and R2, and then configure OSPF on both routers. Note that R2 already has OSPF enabled on its G00 interface, but not the serial interface. I'll configure R1 first. Enable. First, I'll check the interfaces. Show IP interface brief. Okay, so G00 is already configured, but S000 is not. I'll configure it now. Conft interface S000. First, the IP address. IP address 192.168.12.1, 255.255.255.252. Now, the instructions say to set a clock rate of 128 kilobits. We have to do that on the DCE side. Let's check if R1 is the DCE. Do show controllers S000. As you can see, R1 is the DCE. So let's set the clock rate. Clock rate 128,000. Finally, I'll enable the interface. No shutdown. Okay, now I'll configure R2's end. Enable. Show IP interface brief. Like R1, its G00 interface is already configured, but not the serial interface. Conft interface S000. IP address 192.168.12.2, 255.255.255.252. We already know this is the DTE end, since R1 is the DCE end, but let's check anyway. Do show controllers S000. Indeed, it is the DTE end. Okay, let's enable the interface. No shutdown. Now let's enable OSPF on the interfaces. First here on R2, let me see if OSPF is running. Do show IP protocols. Okay, OSPF is running, and it's enabled on the G00 interface. Since I'm already on the S000 interface, I'll just enable OSPF directly here. IP OSPF 1, area 0. By the way, in a real network, I'd recommend being consistent about either enabling OSPF directly on the interface, or using the network command from OSPF config mode. Now both configurations are mixed on R2, but it's not a big deal in a lab like this. Okay, now I'll enable OSPF on R1. First, let's check if OSPF is enabled. Do show IP protocols. Okay, it isn't. Again, I'm already on the interface, so let's enable it here. IP OSPF 1, area 0. And I'll do the same on G00. Interface G00, IP OSPF 1, area 0. Let's check the interfaces. Do show IP OSPF interface S000. Notice the network type of point-to-point is enabled by default. That's because this is a serial interface using the HDLC encapsulation. Also notice that there is no mention of DR or BDR, because as you know, the OSPF point-to-point network type doesn't use the concept of DR and BDR. The default hello and dead timers are 10 and 40 seconds, as expected. Okay, let's check G00. Do show IP OSPF interface G00. Because this is an Ethernet interface, the default network type is broadcast, and R1 is the DR. Because there are no other routers connected to this interface, there is no BDR. Okay, finally, let's see if R1 is learning OSPF routes. Do show IP route. So R1 has learned two routes from OSPF, to the 192.168.34.0/30 network between R3 and R4, and the 192.168.245.0/29 network between R2, R4, and R5. There are some missing routes, so let's move on to the troubleshooting section to fix the network. First up, in step 2, it says that only R3 has a route to 10.0.2.0/24. Well, as we just saw, R1 indeed does not have a route to the network. What could prevent the other routers from learning a route to 10.0.2.0/24? For example, perhaps R3 and R4 aren't successfully forming an OSPF adjacency. Let's check. I'll go on R4. Enable Show IP OSPF Neighbor. As you can see here, R3 and R4 do have a full OSPF adjacency. Is R4 learning a route to 10.0.2.0/24? Show IP route. It isn't. So think back to the lecture video. What could cause R4 to fail to learn a route from R3, even though they have a full OSPF adjacency? Let's check the network type. Show IP OSPF interface G01. R4's G01 interface is using the default broadcast network type. How about on R3? Enable Show IP OSPF interface G01. So R3's G01 is using the point-to-point network type. For a point-to-point connection between two routers like this, it's no problem to use the point-to-point network type, even though it's not the default on Ethernet interfaces. However, when there is a mismatch like this, problems will occur. I'll remove the point-to-point configurations here on R3. Conf-T, interface G01. No IP OSPF network, point-to-point. Okay, let's see if R4 has learned the route. Show IP route. There it is, 10.0.2.0/24. To test if OSPF is working for this part of the network, I'll try a ping from PC1 to PC2. It should work. Ping 10.0.2.1. Okay, the ping works. So R1, R2, R3, and R4 seem to be operating fine. Now let's check step 3, which states that R2 and R4 won't become OSPF neighbors with R5. We just checked R4's neighbor table, and R5 wasn't there. So let's check on R2. Do show IP OSPF neighbor. Indeed, only R1 and R4 appear. Let's check some of the settings on the interfaces in the 192.168.245.0/29 subnet. Here on R2, do show IP OSPF interface G00. The IP address is correctly in the subnet, in area 0, and the timers are default. Those are some basic settings that could cause problems. Next, I'll check R4 again. Show IP OSPF interface G00. R4's interface is in the subnet, is in area 0, and the timers are default. R2 and R4 seem fine, so perhaps the problem is on R5. Let's check. Enable. Show IP OSPF interface G00. The interface is in the correct subnet, in area 0. However, look at the timers. hello timer of 5, and dead timer of 20. These don't match R2 and R4, so R5 won't become OSPF neighbors with them. Let's return R5's timer to the default settings. conft interface G00, no IP OSPF hello interval, no IP OSPF dead interval. Okay, now I'll click this arrow here to skip the simulation forward 30 seconds, and now let's check R5's neighbor table. Do show IP OSPF neighbor. Okay, now R5 is OSPF neighbors with R2 and R4. The next problem is that PC1 and PC2 can't ping external server 8.8.8.8. So, R5 is connected to the internet and should advertise a default route to the other routers. But when checking the routing table of each other router, I never saw a default route. To confirm, I'll try a ping from PC1. Ping 8.8.8.8. The ping doesn't work. So, what's the problem? Let's see if R5 is advertising its default route. I'll go back on R5. Do show running config, section OSPF. The default information originate command is configured, so R5 should be sending a type 5 AS external LSA to the other routers. But perhaps R5 doesn't have a default route. Let's check. Do show IP route. Okay, there's the problem. There is no default route to advertise. I'll configure one. Exit. IP route O.O.O.O, O.O.O.O, 203.0.113.2. Okay, now R5 should create that type 5 LSA and share it with the other routers. So PC1 and PC2 should be able to ping the external server. I'll go check R1's route table. Do show IP route. There it is. It learned the default route from R5. So I'll just try a ping from PC1. Ping 8.8.8.8. Okay, PC1 can ping the external server. Finally, let's check the LSDB. Remember that all routers in the area will have the same LSDB, so it doesn't matter which router you check on. I'll check on R1. Do show IP OSPF database. So these router link states are type 1. Each router advertises its own router LSA. The network link states are type 2. The DR of each multi-access network generates this kind of LSA. Finally, there is one type 5 AS external LSA, sharing the default route from R5. There are many more LSA types than this, but for your CCNA, just know these 3 types. Okay, that's all for this lab. Now let's move on to take a look at a lab in Boson NetSim for CCNA. Okay, here's today's Boson NetSim practice lab, OSPF routes. So this is a fairly short and simple lab. As I've said in the past, there is quite a variety of labs in Boson NetSim. Some of them are larger, more complex, more difficult, and some of them are simpler, like this one. So here's the objective. Learn the commands needed to test an OSPF configuration. Pretty simple. Here are the commands you need to know. These are all commands you already know. The IP addresses of each device, and the lab tasks. There are only 6 short steps in this lab, so let's go through all of them. Step 1. Configure router with the appropriate host name, IP addresses, and also router 1 should be the DCE side of the serial connection between router 1 and router 2. So let's configure that. I'm already in the CLI of router 1, as you can see here. Enable conft hostname router 1, then the IP addresses. So let's check the chart here. First, fast Ethernet 00. IP address 101.1/24, and I'll enable it. Then the serial interface. Now the lab instructions say that this is the DCE side, but we should check just in case. Do show controllers S00. And it says right here, DCE cable. So this is the DCE side. So let's set that clock rate of 64 kilobits per second, which is 64,000 bits. Okay, and enable the interface. Okay, that's all for task 1. Next, task 2 is to do the same on router 2. So to open the CLI of router 2, I click on it here on the right and click on console to open a console connection. Enable conf-t hostname router 2, and then the IP addresses. First, fast Ethernet 00. No shut, and then the serial interface. I'll just check that this is DTE. It should be because router 1 was DCE, but let's make sure. Yes, it is DTE cable. Okay, so let's configure the IP address and enable the interface. Okay, let me just make sure that router 2 can ping the other end, router 1. Okay, no problem. So that is task 2. Next, task 3. On router 1, display the routing table and review the routes displayed. Do show IP route. Okay, it's got connected routes for its connected networks and no OSPF routes. Okay, so that's task 3. Task 4, configure router 1 and router 2 with OSPF so that all devices can ping any other device. Use process ID 1 and area 0. Okay, so first on router 1, router OSPF 1, I'll advertise the fast Ethernet 00 network. 101.0/24 wildcard mask, area 0. And then the serial 00 interface, 192.168.1.0/24, area 0. Okay, that's all for router 1. Next up, router 2. Same deal. Router OSPF 1. First, fast Ethernet 00. 100.0/24 wildcard mask in area 0. And then the serial 00 interface, area 0. Okay, so router 1 and router 2 should become OSPF neighbors. Let's check the neighbor table here on router 2. Okay, init state, still init. I'm going to watch this process. So we're in xstart now. Exchange. Let's see if we can see the loading to full transition. Some of these transitions are pretty quick, so we might not see them. Okay, it went pretty quickly from loading to full, so we missed loading. There it is, full state. So that is task 4. Next, task 5, display the routing table. It says on router 1, but I'll check here on router 2 first. Do show IP route. Okay, it is learning the 192.168.101.0 network here. You can see it in the routing table. Let's check on router 1. Do show IP route. Okay, and router 1 is learning router 2's network, 192.168.100.0/24. Okay, and then the final step, verify your configuration by pinging from host A to host B. All right, let's do that. I'll open up the CLI of host A, and let's do that ping. Ping 192.168.100.2. Okay, we get a reply. So it says here, once you have completed this lab, be sure to check your work by using the grading function. So that is up here, grade lab. If we click it, it will tell us hopefully, yes, we completed the lab successfully. So here are the configurations of each device. If we were missing commands, they would be highlighted in red. If we had any extra unneeded commands, they would be highlighted in blue. But we got everything right. If you ever have any troubles during the lab, you can check Boson's lab solutions down here, which walk you through and give you explanations of each step. Okay, so that's all for this Boson NetSim practice lab. If you want to get a copy of Boson NetSim for CCNA, follow the link in the video description. Before finishing today's video, I want to thank my JCNP level channel members. Recently, I've noticed an increase in the number of channel members, and I'm so thankful to all of you, both JCNA and JCNP level members. Previously, I read out the names of all the JCNP level members one by one, but the list is getting longer, so I'll just leave the list up here. Your support helps me keep making and releasing these videos every week. I'm really grateful for your support. This is the list of JCNP level members at the time of recording, by the way, August 29th, 2020. If you signed up recently and your name isn't on here, don't worry. You'll be in future videos. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.